This ancient secret holds keys to our future innovations. Nature's smallest players are guiding tomorrow's biggest ideas. Imagine a world where complex problems solve themselves effortlessly. This vision is inspired by natural patterns called swarm intelligence. Tiny individuals, working together, create incredible collective power. From ant colonies to bird flocks, nature perfected this system. Scientists now unlock these secrets for revolutionary human technologies. Consider ant colonies, navigating intricate mazes to find food. Each ant follows simple rules, yet the colony finds optimal paths. Bee swarms collectively decide on new nest locations with precision. Thousands of bees vote, reaching consensus through decentralized communication. Starling murmurations display breathtaking aerial ballets in unison. No central leader directs their movements, only local interactions. These natural systems showcase robust, adaptive, and scalable solutions. Their collective behavior minimizes risk while maximizing resource discovery. Swarm intelligence relies on decentralization, a key principle. Each agent acts based on local information, not global commands. Simple rules like follow the neighbor create complex emergent behaviors. Feedback loops, like ant pheromones, amplify successful strategies quickly. This allows groups to adapt rapidly to changing environmental conditions. Such systems are incredibly resilient, even with individual failures. Understanding these algorithms is crucial for future technological leaps. These designs offer models for distributed problem solving in any domain. Researchers are now translating these natural patterns into technology. This field, known as biomimicry, is transforming engineering design. Drone swarms mimic bird flocks for search and rescue operations. Small robots, like those at Harvard, explore dangerous, unknown territories. They collectively map environments and identify hazards without human input. Consider autonomous vehicles coordinating traffic flow, inspired by fish schools. This distributed intelligence promises more efficient, safer urban transport. The U.S. Navy uses swarm principles for autonomous underwater vehicle networks. NASA envisions swarm robots for exploring distant planets like Mars. Tiny probes could autonomously collect data across vast, alien landscapes. In logistics, delivery drones could optimize routes dynamically, like ants. Swarm algorithms are also enhancing cybersecurity, detecting anomalies. Medical nanobots might deliver targeted drugs, inspired by cellular cooperation. However, ethical implications of autonomous swarm decisions require careful thought. Ensuring human oversight remains paramount in these advanced systems. Bias in algorithms must be addressed for equitable, responsible development. Our future hinges on learning from nature's profound wisdom. Integrating these patterns creates resilient, innovative human societies. Nature's elegant patterns offer profound blueprints for our future. Harnessing swarm intelligence will solve complex challenges globally. From efficient cities to space exploration, the potential is vast. These biological algorithms are shaping a more adaptive, resilient world. Want to learn more? Subscribe and join our community.